All right, so when we were doing these three problems in the beginning, these were what we called simple quadratic problems. Why were they simple? Well, because all we needed to do was the same stuff we've already done with solving equations since middle school, where you add and subtract and divide, multiply, whatever, and then also square roots. They are simple because the only thing you see is just an x squared. So the only thing we're going to have to do with that is just the square root. So now I want to talk about complex quadratic problems. So what is a complex? Now again, these words simple, complex, I made those up. There is no like such thing as a complex quadratic problem, but I wanted to differentiate them because they are different. So two examples would be, so let me give you one. Let's say x squared plus 4x equals 9. Okay, that is a complex quadratic problem because it has an x squared and it has an x. So let's talk about, actually, let me give you one more example because we're gonna do an example in a second, but I want to help get these set up in the right place. Because what do we know about this? So what do we know about quadratics so far? Well, there's two things that we know. One thing we've learned about quadratics is factoring. Okay, we did that for a long time. That's our our diamond problems, all of that stuff. The other thing we learned about is the formula. Okay, so we learned two major things, the quadratic formula and factoring. Both of these, we did the same types of problems for. What were we trying to find when we had factoring or formula? Or like when we used the factoring or we used the formula, what was the question always asking for? Great, it was asking for the zeros. Okay, so the zeros is what connected those. We tried to find the zeros. The zeros were the x value where we're at the x-intercepts, right? Or those x values. What did we always know about the zeros? And this is the key. What do we always know about the zeros? 30-second overview of this. So we think about a quadratic graph. Let's say we have a 0 here at -2 and a 0 here at 3. Okay, what is the points there? -2, comma, what? 0. What's the point here? 3, comma, 0. The y values are always 0, even if it was this point and this point. Okay, what's the y value going to be? It's going to be 0. So what we knew about these always was that y equals 0. So this math works because y equals 0. When mathematicians came up with this, how factoring works and how the formula works, it was one of these quadratics where y equals 0, because that's what they were trying to find, was these zeros. How can we rework these equations so that we can find these zeros? Well, y would equal 0 there. That was a principle that they were going off of. So what do I mean? Well, if we think, normally our quadratic equation looks something like this, ax squared plus bx plus c. Well, when we're talking about these two things, the formula or factoring, really we're talking about the formula or the equation 0 equals ax squared plus bx plus c. That was the context in which this worked because of that 0, because that's how it applies to the zeros. It's okay if that doesn't totally make sense, but the important thing is that if we want to use this math, which we do, we want to use this math, either of these things, on these types of problems, well, what's going to connect that? Well, it needs to be equal to 0. Okay, so what we are going to do is look at these two problems, say, okay, I want to set up, I wanted to basically make it look like this over here so that I can use one of these types of math. So I need to get it equal to 0 on one side. You could subtract x squared and subtract 4x and move those over here, but that's a lot more work. What's going to be the easier way to get this equation equal to 0? Well, you only have one term right here. So what you want to do is you're going to want to get rid of this 9. 9 minus 9 is 0. You got to do that to both sides, though. So what's that going to do? You're going to have 0 equals, well, you still have x squared. You still have 4x. And now you're just subtracting a 9. And you're just going to write the minus 9 here because there's no like term to combine it with. Doesn't combine to this one, doesn't combine to this one, so you're just subtracting 9 over here. So this is now the equation in which we can use our factoring on our formula. So now